So it's pretty simple, right? Factoring is pretty simple, but not every single time you're going to get something that's easy to factor. Like the last question that we were doing 2 weeks ago. Let's try this one. There's multiple things going on here, right?
Mhm.
Don't know if this is the best example. What do they want us to do with this? All right, I guess we'll see. The question is just factor. How do we start with this one? It's just straight up factor. That's the only thing they're asking.
You can pull out a 3.
You can pull out a 3, yeah. How about we do one better? We pull out, yeah, we just pull out a 3. That's fine. Actually, can we pull out more than just 3? Always pull out the GCF, which means the maximum things that you could
3x.
possibly, 3x would do it. If you just pull out a 3, it's not gonna help you. I'll give you this one. What goes here?
2.
2,
Negative 2.
-2. What about here?
9.
Just
Y
9?
squared.
9y squared, right? Are we done? Is that it? Or can we go further? What
Now you
about,
do man.
now you can man, right? It's just not in the right form. So I'm just gonna rewrite it like this. Looking for a set of numbers. When they multiply, what do they multiply to?
Negative 18.
-18. What are the numbers? Adds to -17. Do they exist?
Negative 18 and 1.
-18 and +1 would do it. And every single time you're gonna break apart the middle guy, right? This guy. -18y plus y or plus 1y, that's whatever. 3x, what can we pull out from the first two terms there?
9y.
9y, yeah. You're left with y minus 2. What can we pull out from the next two terms?
1.
Yeah, if you can't pull anything out, you pull out a 1, right? Like that. And then your final answer will be 3x, 9y plus 1, and y minus 2. And you're done, okay?
Mm-hmm.
That is it for that one. We're gonna find a super complicated one. This one, 29 is a prime number, so this one could be tricky. Looking for two numbers. When they multiply, what do they multiply to here in this case?
Negative 210.
And they add to -29. Which means, and then they multiply into a negative number, right? Which means you have two numbers here. The bigger one will be negative, okay? And the other one is gonna be positive or negative?
Positive.
It will be positive, that's right. So the smaller one will be positive. This one is not that simple, is it? So let's try. I'm just gonna eyeball this. So let's say -35 and 6. That does it, I think. Let's try. So that adds up to -29, but does it multiply to 210? Yes, it does. Okay, that's how you check it. Um, Usually what you do here, you'll do this, and you'll see that you're way off, okay? So you need to go down this direction. And if you do -40 and 11, you'll be, you'll get something like -440. So you have to go back up here. And then eventually you're gonna reach at 35 and 6, or sometimes it's just like 210, right? That's a number that's divisible by 5, so that's why I picked 35 here. So anyways, negative 35 and 6, whatever. That's the difficult part in this question. After that, it's simple. We don't have to do the whole thing. You understand where this came from?
Mhm.
So you just pick a point, right? And that'll determine the direction you go. You either go up or down, and eventually, if the numbers do exist, you'll figure it out. Let's try that idea with this one. So we know it multiplies to what? What does it multiply to?
42.
42, it adds up to 23. What are the numbers? So multiplies to 42, right? Adds to 23. What are the numbers is the question. Or do they even exist? I think they do.
21 and 2.
Yeah, 21 and 2, and that's it. We're not gonna focus on the whole thing. You know how to man them, right? Like once you have the
Mhm.
two numbers, you just like factor two things at a time. Let's try doing this one. It's more like an economics question, but it's a quadratic basically. It's not that complicated. Now they've given us an equation where P is profit and X is the number of games produced. Okay, part A is asking us for the break-even point. What's a break-even point in this context? What does it mean? You know what break-even means in with respect to profit?
Like when it passes the cost.
Yeah, when it passes the cost. What about with respect to profit? What would the profit be if they break even?
It's 0.
It's 0 exactly. So all you have to do here is just set P, right? P
Mhm.
as 0. So if we set P as 0, it becomes a man problem, right? So what do they multiply to? So we're setting P as 0. We're looking for two numbers that multiplies to what?
Negative 36.
Negative 36 or positive 36?
Positive.
Positive 36. So what are the numbers?
18 and 2.
18 and 2 would do it. So this one we kind of have to do the question. So that'll be plus 18x plus 2x minus 9. What can we pull out from the first two terms? Can we pull out a
2x.
4? Yeah, you can't pull out a 4, so it has to be 2x. Now that's gonna lead us into a problem, which is fine because this is gonna be good practice. You'll get something like this, right? What can we pull out from the next two?
1.
1, right? Now, can we pull out that bracket in this case?
No.
No, we cannot. So we've ran into a problem. How do you solve this problem? So this is very important. Usually, right? Usually, you want to pluck out this sign. You want to pluck out this sign as well. So the +1 is good, but instead of pulling out 2x from the first two terms,
You pull out
you,
negative 2x.
yeah. You pull out a negative 2x, and that should solve it. So negative 2x. If you pull out a negative 2x, you'll be left with 2x minus 9 here, right? Like that.
Mm-hmm.
Now you can solve this. So it's going to become 2x minus 9 minus 2x plus 1 equals 0. I remember the question was, what are the break-even points? Do we go any further, or is this the end of the question? We're gonna go further here because the question here is not the factor. The question here is to solve for x. We need to find the break-even points. What's happened here is this. I don't know what that graph looks like precisely, but I know the negative 9 is the y-intercept, right? And it's a
Mm-hmm.
parabola that opens upside down, so it must go something like this. On the y-axis, you have profit. On the x-axis, you have sales, right? You see right here?
Mm-hmm.
What's the y value here? What's the p value?
0.
0. So this is what we're trying to find. We're trying to find at which x values are p values 0. So what we need to do is we need to solve for x here. So what are going to be our two x's? So how do you solve for x? You're going to set those brackets equal to 0, okay? 2x minus 9 equals 0. What's x?
4.5.
4.5, right? The other one, 2x plus 1 equals 0. What's x?
0.5.
0.5 would do it, yeah. So there you go. But then now gotta answer this in the context of this question. Is the answer to A 4.5 and 0.5? So if they sold 4.5 games, they would break even. Does that sound right?
No.
No, it does not. So what's missing? The unit is missing. How is X quantified here? X is the games produced in 100,000.
800,000.
So we need to multiply that by 100,000. So the answer to A will be 450,000, okay? And
Mm-hmm.
what's 0.5 times 100,000?
It's 50,000.
Yeah, it's 50,000. So if they were to sell for 50,000 and 50,000 games, they would break even. But on our graph, right? Graph doesn't care about the 100,000. Here, when you graph this point is going to be 0.5 and that point is going to be 4.5.
Mm-hmm.
Okay, so that's the answer to part A, 450,000 and 50,000. B, what is the maximum profit the company can earn? Now what is it asking us?
The vertex.
The vertex, right? Actually, B and C, they're both asking us for the vertex. B is asking for the K value, which is the Y value. And C is asking for the H, which is the X value. Remember, vertex is always H comma K. That's the general nomenclature notation. So let's try. How do you find the vertex? Remember, we have the x-intercepts. If you have the x-intercepts, how do you find the vertex? You're gonna find the midpoint, okay? This is called the axis of symmetry right here.
Mm-hmm.
That point up there is gonna be h comma k. To find k, you need to first find h. And h is always gonna be the midpoint, okay? H is always gonna be x1 plus x2 divided by 2, like that. So what's the midpoint between 4.5 and 5?
2.5.
2.5, right? You can just do 4.5 plus 0.5 over 2. That's going to give you 2.5. That means you must sell 250,000 games, okay? 250,000 games must be sold for maximum profit. Now, how do you find the maximum profit? We have the H value. How do you find K?
You plug H back in.
Yeah, you plug H back in there. So P is going to be negative 4 times 2.5 squared plus 20 times 2.5 minus 9, like that. And let's see what that gives us. Are we expecting a positive number or a negative number? Look at our graph, our Y value for the profit. We're expecting a positive number, right? Because we're above the x-axis.
Mm-hmm.
So is $16 the answer to part B? What's the maximum profit? When I plugged 2.5 in there, I got 16. And the answer to that is no, right? Look at the units for profit. It has to be in millions of dollars. So $16 million would be the answer to part B, okay? It's a lot of money, $16 million. And that happens when you sell 250,000 copies of the game. And that's it for this question. Let's look at some more complicated factoring. Let's look at this one. Yeah, let's start with this one. Is this a man question? Again, the goal here is to factor that term, or factor the trinomial. And the answer is yes, it is, okay? There's multiple letters there, multiple variables it's called, but the format is the same. So it is a man question. So we're gonna approach it exactly like how we would approach any other man question. So this one's gonna be tricky, I think. And that's fine, that's the whole point. It's gonna add up to -1, okay? Always pull something out if you can. Here, you can't pull anything out. It does not have a GCF. You can't pull out a 3. You can't pull out S. You can't pull out R from the entire thing. So there's nothing to pull out. So then that means our thing is going to multiply to -420. Okay? Now that's a big number, right? That's a big number. So I'm just going to start somewhere. We know it adds up to a negative number. That means our bigger number is going to be negative, okay? And the other number must be positive because it multiplies to a negative number. So this number is going to be smaller. So now we're just going to start somewhere. Let's start at this. -30. Maybe -30 is too big. Let's start at -20 and 19. Okay, like right there. What does that multiply to? Negative 20 times 19 is negative 380. That means we gotta go down because we need to get to negative 420. And these numbers, I just pulled them out. I usually go either 5 or 10, so I could have... Negative 30 is too big. I realized that this is gonna be way too big. That's why. Now look at this. Negative 21. What's this number here?
20.
20. What does that multiply to?
Negative 420.
And there you go. Those are your numbers. Negative 21 and 20. So even though this looks super weird, right? You'll see that it's just a man question with different variables. From the first two numbers, what can we pull out?
Three S.
So pull out
Negative
the,
3S.
yeah, pull out the negative there, because otherwise we won't be able to go to the next step. So it's gonna be negative 3s. You're left with 4s plus r. What can we pull out from the next two terms?
5R.
5r is good. Then you'll be left with 4s plus, this should have been a 7 here. Yep, 4s plus 7r. Yes, and now we have the answer. So it's going to be 4s plus 7r, negative 3s plus 5r, and you're done, okay? So here the tricky thing was this thing right here. But there is, you just pick a point and you'll see whether to go up or down. Gonna do the same thing with this one. Again, the numbers are gonna be big, but that's fine. 39 is only divisible by 3 and 13, I think. Neither of which goes into 16, so there's nothing to pull out here, okay? And this is also a man question. Looks weird, but it's also a man question. It's power 4, but that just means in our two brackets, instead of having x or whatever, we're going to have x squared. Okay, that's what that means. We're going to have x squared in the two brackets. So we're looking for a set of numbers that adds to 64. It's going to multiply to a huge number, 624. Where do we start with this? The fact that it multiplies to a positive number and adds to a positive number means both of the numbers are going to be positive, okay?
Mhm.
Let's try 30 and 34. That's way too big, 10, 20, so I know I have to go this way, okay? Let's try, again, it has to add up to 64, so 64 minus 25. 25 and 39. Yeah, that's still too big, okay? I'm gonna go 5 down on both of these. Let's go 20. That means this one's gonna be 44. That is 880. I'm gonna go 5 down on both of these. So if this goes down by 5, that's gonna go up by 5, because it has to add up to 64. So let's go 15 and 49. That is 735. We're getting close, okay? 14 and 50 is not gonna do it. Let's try 13 and 52. 2 times 3 is 6, so that's not gonna do it. Let's try, again, you just keep going here. 12, what must this number be? One of the numbers is 12. What's the other number?
52.
Then I messed this one up tonight. This should have been 51, but that's not gonna multiply to a 4, so this one must be 52. And look at this, 2 times 2 is a 4. This could be it, and it is it, and we're done. 624. We found out the numbers. It's 12 and 52. So this is how we'd approach for numbers that multiply big. 16C4. plus 16 going to 52 does not. It doesn't really matter though. 12c squared plus, you're always gonna break down the middle guy there. From the first two, what can we pull out?
Two.
4. Anything else?
4c or 4c squared.
4c squared would be the max things. Then you're left with 4c squared here, plus 3. From the next two, I think you can pull out a 13. 13 goes into both of them. So this will be 4c squared plus 3 as well. Then finally, your answer is going to be 4c squared plus 13 and 4c squared plus 3. Okay, now we've factored this, and that's the end of the question. So there's a 4 here. It's going to be split up into squared and squared. There's a 6 there. It's going to split up into cube and cube. It's the same idea.
Mm-hmm.
This one is also looking weird. 39 is a weird number. 39 is only divisible by 3 and 13, neither of which go into 14. Now you're going to help me solve this. The first step is very simple. It's going to add up to negative 39, and then it's going to multiply to 27 times 14, 378. So tell me, what do our numbers look like? Are they both positive? Is one of them negative, one of them positive? What's going on here?
They're both negative.
They're both negative, exactly. Now I'm just going to pick a point, right? You can pick anything. I'm going to try negative 30 and negative 9. Does that multiply to 370? Not quite enough. It's 270. That means we have to make this bigger, right? 31 and negative 8. That's going the wrong way. So that means we must go this way, okay?
Mm-hmm.
So we're gonna try 29 and 10. That's not gonna multiply to an 8. At the end here, we're looking for an 8. Okay, look at this. This is gonna save you some time. So negative 29 and 10, you don't even have to check it. Negative 28 and what will this be? 11? Yeah. I think this will do it. Maybe, maybe not. Actually, no, I don't think it's gonna do it. I got 308, so that's not good. Negative 27 and 12. That doesn't multiply to an 8 at the bottom, so at the end, so that's out. So the next one will be negative 26 and negative 13. Now this one does multiply to an 8 at the end, so this could be it. Negative 26 times negative 13. That is positive 338. So that is not it. Negative 25 and negative 14 cannot be it because that multiplies to a 0. Negative 24 and negative 15 cannot be it, yeah? Negative 23 and negative 16. Can this be it? 6 and 3 multiplies to an 8, so that's a good contender. But not quite enough though. That's 368. 27 times 14 is 378, so that ain't it. So negative 22. What's the other number here?
Negative 17.
So that doesn't multiply to an 8, so that's out. Negative 21 and negative 18. Let's check for this one. And that's the one. This is our guy, okay? So sometimes it takes a while. Yeah, I should probably check for negative 25 straight up to see the pattern. But those are our numbers, negative 21 and negative 18. This method almost always works, but sometimes it does not. So I don't know what that even means, but 99% of the time it's gonna work this way. Because this way you kind of like exhaust all the possibilities. So negative 21 v squared minus negative v cubed, sorry, not squared, 27. What can we pull out from the first two terms?
7v cubed.
7v cubed will do it. So you're left with what? 2v to the power of
3.
3, yeah. Minus 3, and then from the next two, you can pull out a 9. You're left with 2v cubed minus 3 as well. So you have 2v cubed minus 3 times 7v cubed minus 9. And that's the end of the question. Make sense? This part is a tricky part here, right? Coming up with these numbers, and that's always going to be the case when you're dealing with numbers in the hundreds or in the thousands. Okay, we'll just do one of these. It says factor. Do we open the brackets?
No.
We don't open the brackets, so what do we do? The goal is to factor it. Is there something that we can pull out? Think about it this way, right? What if instead of this, I gave you something like 12a4 plus 52a squared minus 40? How would you approach this question? Is that a man question, this one? Yeah, it is, right? That's a man question. So it's the same kind of idea here. What I'm gonna do is, I know the a minus 2 looks a little bit wonky, but we're gonna forget about that. Or if you really want to, you can do something like this. We can let that bracket be a different variable, which means our question becomes 12x4 plus 52x squared minus 40, from which I can pull out a 4, 3x4 plus 13x squared minus 10. Okay, like that. Now we're looking for a set of numbers that multiplies to negative 30, adds to positive 13. What are the numbers? Multiplies to negative 30, adds to positive 13.
15 and negative 2.
15 and negative 2. So 4, 3x4 plus 15x squared minus 2x squared minus 10, like that. From the first two, we can pull out a 3x squared. We'll be left with x squared plus 5. What can we pull out from the next two?
Negative 2.
Like that, and then you'll have something like this, right? But the answer, the final answer there, even though it's fully factored here, we don't have an x in the question to begin with. That means your final answer should not have an x. So now we're gonna replace whatever x is. So our x, it's gonna look something like this. Our x is a minus 2, right? So replace this x with a minus 2. It's gonna become a minus 2 squared. Replace the other x with a minus 2 as well. Like that. Cool? And that's the end of the question, I think. I really don't want to go any deeper, but let's check. Let's just check for completeness. If you open this bracket, you'll get a squared minus 4a plus 4 minus 2, that's 3a squared minus 12a plus 12 minus 2 is negative 10. So it's going to look like that. And that's going to be a squared minus 4a plus 9. I just opened up the squares and cleaned it up. For here, we're looking for two numbers that multiplies to 9 and adds to negative 4. The only thing that multiplies to 9 is 9 and 1 and 3 and 3. There's no way that adds to negative 4, so you can't factor that. Here, we're looking for two numbers that multiply to negative 30 and add to negative 12. Do they exist? I don't think so, right? 15, 2, 3, 10, 6, 5. That's the only combination, and none of them will add up to negative 12. So you can't factor that either. So that would be the last step right here. If you don't want to, you don't have to open the brackets, but you probably should. And just check just in case you can go further, right?
Mm-hmm.
So that's how you do it. It looks very weird, but you can just replace one of them with something else. All right, let's look at this. Again, the goal is to factor, but you'll see that this one's gonna be a little bit special. How do we start with this one? The goal is to factor it.
You do, man.
You do, man. What do they multiply to?
400.
400, right? And it's gonna add up to negative 40. What are the numbers?
Negative 20 and negative 20.
Yeah, negative 20 and negative 20. So now we're gonna do 25x squared minus 20x minus 20x plus 16. Pull out a 5x from the first one, you're gonna be left with 5x minus 4. Pull out a 4 from the next one, you'll be left with 5x minus 4. So you have 5x minus 4 times 5x minus 4, yeah? Now look at this, you have 5x minus 4 squared. Yeah.
Mm-hmm.
So that is called a perfect square. Perfect square is when two of the thing becomes the same. Okay?
Uh-huh.
Difference of squares, we've done this. It's not that difficult. So now we're factoring. We're moving away from, I don't know for how long, but so far everything we've done, the man things only applies to a quadratic trinomial. If you have a quadratic binomial, doesn't necessarily have to be x squared. By quadratic, I mean you can square it, okay? You have something squared, like 81x4 is 9x squared squared. Now, if you have a quadratic binomial, to factor this, you are going to need to use the difference of squares. Which says the formula for difference of squares is if you have anything in this form, a squared minus b squared, You're gonna get a minus b, a plus b. The order here is not important. You can rewrite that as a plus b times a minus b. They're both the exact same things. The order doesn't really matter. Look at a. How do we factor that? So compare this with a squared, okay? Compare this with b squared. If a squared is x squared, what's a?
X.
X. If b squared is 64, what's b?
8.
8. Now you just follow that formula. So a squared minus b squared becomes a, which is x, minus b, so 8, and it becomes x plus 8. And that's it. That's the end of the question. It's just a one-step thing. This is also a one-step thing, but slightly more complicated. If a squared is 81x to the power of 4, what is a?
9x squared.
9x squared. If b squared is negative 25y squared, what's b? Sorry, that there's no negative sign there. If b squared is 25y squared, what's b?
5y.
5y, right? So what's the final answer? So the final answer will be, you just rewrite it in this form, right? You go to 9x squared a minus b, and then you do a plus b. Cool?
Mhm.
And that's it. That's the difference of squares. It's not that complicated at all. It's just once you know it, you know it. I'm not gonna worry about these boxes. I'm not a big fan of those. The boxes, I guess, is a little bit elementary. You would do it this way if you're in like grade 5 or something. But at this level, there's no point. No one has time to draw out these boxes. You could though if you really wanted to, but I don't think it's important. I'm trying to find some interesting questions. Most of these are pretty simple. In fact, a lot of these are just one-step questions. Look at question 5. Everything there is a straight up one-step question. It's just a difference of squares. Like for example, the hardest one, F, is just 5d minus 12, 5d plus 12. E will be 3x minus 2, 3x plus 2, just like that. What will be the answer to D? What's the square root of 4c squared? That's going to be your A value.
2c.
Yeah,
And then minus 7.
and see, all these are just one-step answers. That's super elementary. Not going to waste time with that. Gonna waste time with notice a trend here. Actually, look at question 6. What do you notice about all these numbers?
They're perfect squares.
They're perfect squares, right? So that means if you just do one of these guys, the pattern should be pretty obvious. If it's a perfect square, check for half of the b value. What do I mean by that? When this multiplies to 225, right? When it adds up to negative 30, if it's a perfect square, the numbers are going to be exactly half of this, and you can double check that. In this case, it checks out. 15 times 15 is 225, and it also adds up to negative 30. Cool?
Mm-hmm.
So if it's a perfect square, check for half of whatever the number is adding up to. Like here, it's going to be 36, 36, I bet, but we can double check that. So it's going to multiply to 81 times 16, which is 1296. It's going to add up to 72. I'm thinking 36, 36. Let's try 36 times 36, and yes, it works out. So more often than not, it's gonna be exact. In fact, every single time, if it's a perfect square, your two numbers are going to be exactly half of whatever the b value there is. Okay, here, let's do some mental maths. So they want us to find the answers to these, right? But we cannot use a calculator, okay? We cannot use a calculator, so how can we rewrite a? It's in the form of a difference of squares.
It just becomes 64 minus 60 and then 64 plus 60.
64 minus 60 and 64 plus 60, right? So this is a 4. That is going to be a 124, yeah?
Mm-hmm.
So this one, you can further rewrite this as something like this. If you're trying to do this in your head. 12 times 4 is 48. That means 120 times 4 is 480. And then 4 times 4 is 16. So the answer is 496. And you're done. Same thing with this one. It's going to become 18 minus 12 times 18 plus 12. It'll be 30 times 6. What's 30 times 6?
180.
180, and you're done. You don't need a calculator if you have something in this form. So they've given us something and it says why it cannot be factored as. Well, it cannot be factored as a difference of squares because it's not a binomial. There's 3 terms in there, right?
Mm-hmm.
So the answer to B is that, well, because there's 3 terms in there, you can't find a difference of squares. And for a perfect square, your two numbers are always going to be half of that B value. Now, if you check here, man, this is going to multiply to what's 8 times 9?
72.
72, right? And it adds up to negative 18. Your numbers, you'd expect it to be negative 9, negative 9. But are they negative 9, negative 9? No,
No.
because it doesn't multiply to 72. So that's how we know this thing is not a perfect square. Even if you factor it, it won't be a perfect square, okay? You don't have to factor it, but which one should we do? Honestly, it doesn't really matter. I think 17 squared is 289. Let me double check that I think that's right. Yeah. So 17 squared is 289. Use the difference of squares. What does this factor out to?
Um, 17x to the power of 4 minus 9. And then you do plus.
Does that sound right though? Let's see. 17x is right, but the power 4, I don't know. Because if you were to multiply these guys, what's x4 times x4?
X to the power of 8.
Right, but we don't have x power 8. We have x power 6. There's a quick tip. When we're doing a difference of squares, you're square rooting it, okay? When you square root it, the power cuts in half. So square root of 289x6 is 17x3.
Okay.
The power always cuts exactly in half. You can have something weird like 36y80x120z64 or something like that. That's going to become 6. Square root of 36 is a 6. Square root of y80 is y40. Square root of x120 is x60. And 64 becomes a 32. That's a square root, okay?
So it just divides by the index.
Yeah, exactly. So if it's a cube root, you're gonna divide by 3, all the powers, and if you remember that, that'll help you a lot. These questions are super simple. It's just a one-step thing, right? You don't even have to think much for these questions. Oh, this one is extremely tricky. $10 if you get this, or if you can come up with a strategy to factor this. The goal is to factor it. I'll give you a hint. You have to rearrange some things to be able to see it. It's tricky, right? Here, let me give you a hint. That's a 16 there, okay? I'm gonna do this. Like that. Let's man this. Multiplies to 16, adds to -4. What are the numbers? Sorry, adds to -8. What are the numbers?
-4, -4.
Yes. Now, if the leading coefficient is the number that's multiplied with the x squared term. If the leading coefficient is a 1, okay, you can skip some steps. You can just do, hey, I know that's going to factor out to x minus 4 and x minus 4, okay? Which is x minus 4 squared minus c squared. Now look at this. We had a man, now we have a difference of squares. What does that factor out to?
X minus 4 minus c.
Yeah. And then x minus 4 plus c, okay? And you're done. That's it. Using that logic, can we do this? Which 3 are we supposed to pair together, or which one are we supposed to toss to the side? This one's even more trickier than the last time, but the idea is the same. You gotta rearrange it.
You toss the 4c squared aside.
All right, let's do that. So we have -a squared minus 6ab minus 9b squared plus 4c squared, right? Which we can write as plus 2c squared, 2c whole squared. Do we have a formula for a sum of squares? We don't, okay? We do not have a formula for sum of squares. So this one as it is we can't really factor it. But what if we pull out a negative sign? The first one is gonna become 6ab plus 9b squared, yeah? Now look at this, this plus sign is gonna become negative. And that's the trick for this question. You'll have negative. That one is 3 and 3. I'm just skipping a step here, but that's what it factors out to. That means our final answer here will be negative a plus 3b minus 2c, okay? Times, because this is a squared, it's gonna be a plus 3b plus 2c, and that'll be the final answer for this question. And that's as hard as it gets when it comes to man and difference of squares, when they kind of compile it and when you have to throw things to the side. Did that make sense? You understand how we went from here to here? I just manned it. You multiply to 9, adds to 6, the numbers are 3 and 3. If the leading coefficient is 1, you can kind of like skip a step. The hardest part here is taking out the negative sign. If you don't take it out, you can't really do much. All right, let's call it a day there.
Okay, thank you.
See ya.